Good evening, everyone. Pichani comes. Let's start off. Comes on, everyone. Hope everyone has gone through the notes. Utsa, you need to come from next week. Right?
So
Chapter
next,
still not over.
yeah,
Next week.
okay. Actually, Vimi ma'am asked me to join from today.
I think she got confused. It's like this chapter still 2 more classes are needed, so you can come from next Wednesday.
Okay, sir. Sure. Bye, sir.
Chalo, other scams on. Hope has everyone gotten the notes, and the test ka deadline is tomorrow. Hope everyone has given the test. Do make sure to give in case you forgot. Great. Let's see. Let's start off with a question. Actually, not much is left, so I thought we'll just have 2 Arca class, and from next week we will make it 2.5. So don't worry about that part. And next weekend, mostly we'll have a PTM. So we'll be dividing you all into some groups of 6, 7, and then I'll take PTM separately for all of you. I'll inform you by weekend. Let's see. So this was the last thing. Let's start off with an easy one, and then we'll go ahead. And do start finishing off your booklet and HCV or DC Bande or my booklet, whatever you're doing, do start finishing off this material. So let's say we have a lens whose refractive index is mu is equal to 2 on the top and mu is equal to 3 by 2 at the bottom. So it's a lens made of 2 different materials. Radius is r, radius is r. Object is here at a distance of 3r. Getting it? So find the position of the images. What if you make a lens of 2 different mediums? Let's get this. Who is missing? What is the catch? What if you make a lens of 2 different mediums? Anyone? Do you remember in mirrors we did this thing? If you take a mirror and if you break a piece of it, what happens? It still behaves like a full mirror. So here also it is the same thing. Only the intensity will change. So here the logic is even a part of the lens behaves like a full lens. Only the intensity will change. So what you can do is this here can be treated as 2 lenses. One lens of mu is equal to 2 and one lens of mu is equal to 3 by 2. Got it? So you just treat them like 2 different lenses and solve the question. So this is the object here. So focal length will be 2 minus 1 by 2 by r. So that is 2 by r. So 1 by V minus 1 by minus 3R is equal to 2 by R. How much is this? 2 by R minus 1 by 3R, 6 minus 1, 3R by 5. So we get V is equal to 3R by 5. So you get one image at 3R by 5. Here what you do, you just treat this as 3 by 2 minus 1, 2 by R. This is 1 by R. 1 minus 1 by 3 is 2 by 3. We get V is equal to 3R by 2. So we get the second image at 3R by 2. So basically we get two different images. Please check. Yeah. So if you try to trace the light rays, this is how it would look. All the light rays which go top, they meet here, I1. All the light rays which go below, they meet somewhere here, I2. So you get two different images. The intensity becomes half. Clear with this? This is not the actual question. Meaning this is a decent one, a mains level one. But let me show you how they can trim a better one. Any doubts on this? Anyone not clear with this? Please ask. Rehan, clear with this? Arjun? Clear, na? Yasha? Clear? Ali? Palaksh? Turning the page? Swastika, got this? No. A better version of this question is, we have a lens, radius r, the refractive index mu is equal to 2 plus y square. This point y is equal to 0, this point y is equal to 1, this point y is equal to minus 1. Means it's a lens whose refractive index is changing with y. At different heights, you have different refractive index. For example, when y is 0, here refractive index is mu is equal to 2. When y is equal to 1, refractive index mu is equal to 3. Are you getting? As you go up, lens ka refractive index is increasing. So mu increases with y. You have an object here at a distance of 3r. Find the length of the image. Assume all light rays are paraxial. Now try. You got 2-3 minutes. The previous one was the theory for this. So let's see. Anyone didn't get the question, please ask me. You got a lens whose refractive index is changing with height. So center pe y is 0 to 2, highest point mein 3. Mu is not same anywhere, meaning this is made of infinite lenses, isn't it? How do we do this? Think. It's a good one. What is the logic behind this? Just think from the previous question, okay? Suppose if this was made of four mediums, mu1, mu2, mu3, mu4, how many images will form? 1, 2, 3, 4. Agreed? That means whatever light ray which will go here, that will form one image. Light ray which will go here will form one image. Means all the images will lie between these 2 points now. Is that making sense? The light ray is going from the center and the light ray is going from the edge. All images should lie between these 2 points. Is that making sense? That means what is the length of the image? The distance between the 2 points. So first assume mu is equal to 2 and find the image. Then assume mu is equal to 3 and find the image. So all the points between 2 and 3, these 2 points, is the length of the image. Is that logic making sense? So you get infinite points. So when you have infinite points, it becomes a straight line. Got it? So this is how you can make a line with a single point. Okay, we have 2 different answers. 4 different answers. 7R, 18R by 55, 6R by 35, 2R. I'm not sure. So here the logic is that all the images lie between images formed by mu is equal to 2 and mu is equal to 3 lengths. Is that making sense? The extreme light rays will meet somewhere. The light rays near the center will meet somewhere. Everyone else has to be in the middle. Then it is easy to solve. Only that mu is equal to 2 plus y square is to scare you. So all these will go somewhere and meet here. Let's calculate that. So at y is equal to 0, mu is equal to 2. The focal length will be 2 minus 1. 1 by r minus 1 by r is 2 by r. 2 by r. 1 by v by minus 3r is equal to 2 by r. How much is this? 6 to 3r by 5. We just calculated this. At y is equal to 1, mu is equal to 3. 1 by focal length is 3 minus 1 by 2 by r. So 4 by r. So this guy will form an image at I don't think you'll get a good number. V is equal to 3r by 11. So basically, this 3r guy is meeting close here. These light rays here will meet somewhere here. So this is 3r by 5. This is 3r by 11. So all the remaining spots should lie between them. This is the image. So the length of the image would be 3r by 5 minus 3r by 11. 11 minus 5. How much is that? 6, 6, 3 is 18r by 55. Yasha, Niranjan, Anusha, yep, and Nika, you all got it right. There we have 4 right answers. Others do check it out. Yasha, why minus sign? Length of the image, na? You just reversed it. No probs. Yeah. Any doubts on this? Please ask me. Sure, everyone? Next one. Any doubts on this? So whenever you see a refractable index, right, this is how you can figure it out. Next one is a good one, right? This again is going to come in wave optics. This can be a proper advanced question if I combine wave optics, but let's see for now. So let's say we have a lens. R is 20 centimeters and mu is equal to 2. Now what someone did, this is the object at a distance of 30 centimeters. Someone removed 2 centimeters from the middle. So they removed 1 centimeter above the principal axis and 1 centimeter above the principal axis. And then these two parts are joined. Object is still on the same line. Everything else is same. So a thickness of 2 centimeters is removed from the middle as shown. So you removed 1 centimeter above the principal axis, 1 centimeter below the principal axis, and you join them. And remaining parts are joined again. Find the position of the images. Let's get this. Let's see how you figure out the catch. I hope the diagram is clear. Venkatesh, do keep your cam on. Vartika, do adjust your cam. I can't see you. Do something about it. I should be able to see your full face, everyone. Who knows, you might be eating chocolate secretly. We don't want people doing that. Venkatesh, you also. Vartika, still adjust a bit. You have a problem with the camera or you're feeling shy? Say na problem with camera. That'll be better. Chalega. Venkatesh, please don't be shy. Do adjust your cam. Just swing it down a bit. I can't see you. All we can see is your beautiful hairstyle. Let's get this. Neil, answers, how to solve. Anika, try. Maulika, Adrit. How do we proceed with this? R changes. No, Anusha, why will R change? Suppose if you take a surface like this, if I just break this, the radius of curvature is still same, right? R change nahi hoga. Think for another 30-40 seconds, then I'll tell you what. Actually, instead of thinking what changes, tell me what doesn't change. That is a better way of asking. Focal length, ठीक है. Focal length won't change. What else? suppose if I have a lens like this, if I break all this lens, मतलब सिर्फ इतना part है, what remains same? The principal axis. You're getting it? The principal axis will be at the same place. This small part of the lens will behave as if it is a full lens with the principal axis at this place. Is that making sense? Now here what you did, you cut the lens. Chalo, I'm okay with that. Problem uske baad tha, you moved them. Are you getting the point? If I cut this lens and if I move this part little below, what will happen? Won't the principal axis also move? समझ में आ रहा है? Cutting a lens is not a problem. Moving a lens is a problem. The moment you cut 1 centimeter and you moved it down, you messed up the principal axis for each part. Are you getting what is happening a bit? Kuch idea aaya? Think. I'll give you another minute or 2 minutes. Then I'll show you. So that is the main idea. Cutting a lens, you never have a problem. Cutting a lens and moving it is a problem. Because the moment you move, the principal axis changes. You can do the same thing with mirrors also. Think what happened. You got 2 minutes.
Sir, but if you remove it equally from both the sides, the principal axis won't change, no?
Think. Yeah. The two parts will have two different principal axes. ऊपर वाले का principal axis you moved it down. Lower वाले का principal axis you moved it up.
So it won't coincide.
They won't coincide, ना? देखो diagram ऐसे दिखेगा everyone. You're cutting this, ना? You cut it here. तो इसका principal axis was here, isn't it? 1 centimeter. इसका principal axis, I'll show it with a green line. This is 1 centimeter. Agreed. This was the before cutting. Now, when you joined them, what will happen to the red line? When you join them, the red line will go down here, isn't it? So this would be 1 centimeter. So if you push this 1 centimeter down, the principal axis from here also will shift 1 centimeter down. Is that making sense? And this lower lens, what will happen? This lower lens, you're pushing it up. Iska principal axis will shift up 1 centimeter. Are you getting? The two principal axes will go up and down. There'll be two images. So let me show you how that happens. So by cutting a lens, when a lens is cut, the principal axis remains same. So let me show it like this. So the upper part of the lens, so this is the lower part of the lens. This was the principal axis. So object was here. This is the principal axis. 1 centimeter each. Now, the moment you join them, this is what happens. So you're bringing, they're joining them, no? So this black line which is there, you brought it here, but remember, this red ka principal axis will be here. This is your principal axis now. And this green one, you made it touch the black line, the previous principal axis. So for the green line, this is the principal axis. I'll just call it as PA. So for this question, object is here. For this question, object is here. So the lenses will think the objects are at a height of 1 centimeter above the principal axis. Are you getting this? So this is 1 centimeter and this is 1 centimeter. Is this making sense, everyone? This black line is your old principal axis. So the lenses will feel the object is at a height of 1 centimeter above the principal axis. Is this understood, everyone? Clear with this or confusing? So this was the old line, no? The diagram would be, you joined like this. You joined like this. So red wale ka principal axis will be here. And the green wale ka principal axis will be here. This is how the diagram will look. The two principal axes would move 1 centimeter up and down. Sure, everyone? And then you can actually calculate what is the radius. 2020, na? That won't change. The focal length will be 2 minus 1, 2 by 20, so 1 by 10. So 1 by V minus 30. 1 by 10, V is equal to 15 centimeters, and magnification is V by U is 15 by minus 30, so minus half. Magnification is minus half. Please check. Question is still not over. Now we have to find the location of the images. Any doubts on this page? Please look at step by step. Quite a good question. This is how they'll frame a question in advance. And advance mein paragraph mein, this is a part of the question. Any doubts on this? Anyone not convinced with why the principal axis moved or what is the distance? Anything you didn't get, please ask. Don't hesitate. Get it cleared. Rehan, clear with this? Sure, na? Swastika, Vartika? Sure? Swastika, clear, na? Adrit, Aditya? Adrit? Adrit, are you there? This guy is not there. Adrit, are you there? He's not there. You're not there. What are you doing, Adrit? Hello, are you there? Can you respond, Adrit? That guy seriously looking back. Respond करो रे माइक काम नहीं कर रहा है क्या अदृत अदृत are you there? What is this guy doing रे? Seriously? I think his mic is not working. ठीक है say that na. I said there's a snake, so seriously the grass snake. Chalo, theek hai. Now, question is still not over. So look at this thing. Remember, this was the
Sir,
old principal axis. Ah, God.
sir, so if you cut the lens once 1 centimeter and then the remaining lens, if you cut it again by 1 centimeter, then the principal axis will shift down by 2 centimeters.
Perfect. Perfect. That's what happens. Adrit, can you hear me now? See, just check your mic settings. Okay. Maybe you are lagging, I guess. Let me know if you're not able to hear. So listen carefully. Yeah? This is where people goof up. After doing this much, they goof up. This is the new principal axis. The object is here, 1 centimeter. So what did you got? You got 15 centimeters and magnification is minus half. Meaning from this location, let's call it O dash, the image will be somewhere here, I dash, and magnification is half. So this will be this way, half centimeter. Meaning from the actual location, the image is actually 3 by 2 centimeters below. That means if this was the lens, and this was the lens, the object here will form here I1 at a distance of 3 by 2 centimeters. And the green one will form an image here I2 at a distance of 3 by 2 centimeters. Object is here and this distance is 15 centimeters. Please check. So the distance between the object is how much? 3 centimeters. Most people goof up this part. The magnification half is from the new principal axis. It's not from the old principal axis. Most people will write half from here. Be careful. So the principal axis, the distance will be half centimeters below the new principal axis. Please check this out. That itself is a pretty good question. Find the distance between the images. I hope this was clear. Please ask me if you're confused. Magnification minus half, meaning, remember, this is from new principal axis. That's it. You just have to be careful with that old and the new thing. Sure, everyone? It's a pretty good one. You should definitely try this on your own again. Next one, turning the page. Any doubts on this? Great. Next thing. Lens displacement method. This is kind of theory. And also, you get a lot of good questions on this. So lens displacement method is an experiment. So this is an experiment to find focal length of a lens. So what we're doing this, consider a fixed object. To keep the object fixed and a fixed screen. With the distance capital D between them. Right? And have a movable lens. right? So what we do here, the lens is adjusted. You keep moving the lens. The lens is adjusted till we get a clear image on the screen. And we observe this happens for two positions. We observe there are two positions of the lens for which the image forms. Okay, so let me show you how the diagram looks. So we have the screen here. We have the object here. This is fixed. This distance is capital D. So first, let's say you keep the lens here. So light rays will go through this and they form somewhere here image. So let this distance be X and let this distance be Y. So this is position 1. Position 2, you move the lens by a small distance T. This was the old position. You move this lens by small d. We observe again the image forms on the screen. Now we know from principle of reversibility, right? If the object and image are interchanged, so if you put the object in the place of an image, you get the same distance there. So this distance would be Y and this distance would be X. If you apply the lens maker equation, you'll observe you'll get the same equation in both of them. See, I'll show you. So here capital D is the distance between screen and object. Small d is the distance moved by lens. So if you apply the lens maker equation, look at this thing. You apply position 1 or position to see what happens. 1 by V, V is Y here, minus 1 by U is minus X, is equal to 1 by F. Suppose if I use a second position, here V is X and U is 1 by minus Y is equal to 1 by F. Did you see both the equations are same? So you can interchange X and Y and you still get the same thing. So the meaning of this is this, right? Suppose let's say if you keep the object here, 20 centimeter, and let's say image you got 30 centimeter. Suppose if you keep the object at 30 centimeter, you get the image at 20 centimeter. They'll exchange. Get the meaning of this? So if you put the object in the place of image, you get the image in the place of the old object. So if I simplify this, you end up with X plus Y by X, Y is equal to 1 by F. This is your equation 1 from the lens maker equation. Second equation, you can clearly see from here, X plus Y is capital D. That is second equation. Third, you can see here X plus small d is also equal to Y. That means Y minus X is small d. This is your third equation. Please check your equations. One is from lens maker equation, one is X plus Y is equal to capital D, and one is X plus D is equal to Y. Just distances. Anyone not clear with this page, please ask me. Anyone didn't understand any particular diagram? What is distance? What is X, Y, F, anything? Clear? Then I'll write these equations on the next page again. So x plus y by xy is 1 by f. X plus y is capital D. Y minus x is equal to small d. So substitute here. So x plus, so if you just add them here, you end up with y is equal to d plus d by 2. And x is equal to d minus d by 2. Substitute here. This guy would be capital D by d square minus d square by 4 is equal to 1 by focal length. We end up with focal length is equal to d square minus d square by 4d. There. This is how you can find the focal length with just the distances. This is an important result. Look at this experiment. You know nothing about the lens. Lens का refractive index पता नहीं है, lens का radius पता नहीं, कुछ भी idea नहीं है. All you did was you measured capital D, you measured small d, and you got the focal length answer. You're getting it? So from the focal length, you can actually find the refractive index of the material. You can go reverse. So this is an experiment to find the focal length of a lens just using distances. So position 1, you kept the lens some distance, and look at the best part. I don't even know what is x and y. I don't care. I just know distance between object and screen. That much I know, and I know how much I moved the lens. These two are easily calculatable. You can calculate them easily, and just put them and you get the answer. So this thing is pretty good results. So this can be written as d square minus 4df minus d square is equal to 0. So if you take out d common, this is 4df. This will be d minus 4f is equal to d square. This should be greater than or equal to 0. That means d should be greater than or equal to 4f. Again, this is important thing. The distance between the object and the screen should be at least 4f. So if d is less than 4f, we won't get an image on the screen. Then remember in the beginning, we wrote a statement once. The minimum distance between object and image is 4f. So this implies the minimum distance. These are theoretical equations. Means in a lens, if you have a real image and a real object, the minimum distance between real object and real image is 4f. You can't have anything less than that. Quite a useful one. So this happens when we place the object at 2f. This is the minimum distance. You can't get anything less than this. Check it out. So this is the first result. This is the second, not a result, but a statement. So do have a look at this page. Previous page here. First page theory, this one here. So it's an experiment to find focal length of a lens. So you know where is the object, you know where is the screen, that is capital D. And when you move the lens, you know how much you move. So that is small d. You got focal length. And you just have to keep moving till you get a good image though. Clear? Please check this thing.
Sir,
Abhinav.
is this the concept by which binoculars work because you keep adjusting it? It goes front and back and
Yeah, basically your eye is the screen. Binoculars is the lens. So what you're doing is here you can't change the distance, you're changing the focal length.
you are changing it.
That is the idea in binoculars. Kitna kyun? People who are using glasses, isn't the same thing for us? Because you can't change the distance between your retina and the eye ka this thing. So that is fixed. So you have to keep changing your glasses ka power so that the image forms on the retina ka screen. Your retina is your screen basically. That's what happens when you go to the eye doctor. He just keep putting different lenses. He'll say, this is clear, this is clear, this is better, this is better. Next one. Turn the page. Any dots on this page? Now, if you look at it in position 1, you'll be having a ray optics ka test this Saturday, right? It'll be all basic, mirrors and lenses. So whatever we did till last class. So you really won't have high content. It'll be simple basics only. It's mains level ka thoda theoretical paper hai. So if you have done everything till last class properly, you'll be able to handle it. So do finish it off. Once you finish off this, I'll send you a proper advanced assignment sheet on full ray optics, maybe like 60, 70 questions. That will take care of everything. But first finish off your booklet or whatever book you're solving. In case you're done, just ping me. I'll send you before and Nathan I'll send you anyway next week. So in position 1, if you keep the object here, let's say some height. And when you keep the lens here, this is X, this is Y. So you get some image here, image 1. And this height will be H1. So what is the magnification? Magnification M1 is V by U, V is Y, and U is minus X. This will be height of the image by height of the object. This question was asked in the mains exam. I'll show you what they asked. The same thing, you didn't change the object position, but you moved the lens somewhere here. This guy became Y and this guy became X. Again, you got a new image, I2, H2. So this magnification will be M2, again V by U, but remember V became X and U became minus Y. This is height of the object H2 by H. If you multiply M1 into M2, you actually get 1. They cancel out. That means H1 by H, H2 by H is equal to 1. H1, H2 is equal to H square. Quite an important result. The height of the object is root over height of the image in the first position and height of the image in the second position. And the magnification M1, M2 is equal to 1. The exam में question ऐसा पूछा था. In a lens displacement method, in the position 1, the height of the image was 9 centimeter. In position 2, the height of the image was 4 centimeter. Find the height of the object. So they said H1 was 9 and they said H2 was 4. Height of the object is how much? 6. But that was an easy 4 marks question if you know the result. That's how the question was framed. The example, lens displacement method. Height of image in position 1 and 2 is 9 centimeter and 4 centimeter. The height of the object will be root over 9 into 4 is 6 centimeter. That's the question. Here I'm telling you, mains they won't ask you something out of the world. Mains is like they just ask you pretty straightforward single concept questions. They don't mix it up. So if you follow the notes properly, do all your work, mains में getting 90 marks is quite easy in physics. That much you need to score. Because if the paper comes like last year, max will slaughter you. Doubt ही नहीं है. If the paper comes like last year, max you will get slaughtered. Last year, I told you, right? People who got 82 out of 100 in physics is 99 percentile. 42 out of 100 in maths is 99 percentile. 42 marks in maths is equivalent to 82 marks in physics. But luckily, end of the day, JEE mains ka rank comes on total score. No one cares about individual marks. Last year, Sanit जिसको mains में rank 600 आया था, he scored 44 or 45 in maths. Physics he scored 92. That covered up everything. Because paper is easy, nothing much. I don't know why they're giving maths so very deadly paper. But ठीक है. But there's no guarantee. Next year paper can be easy also. क्या पता. Clear with this thing? So in this lens distance method, right, these are the 4 important results. Focal length, minimum distance is 4f, magnification product is 1, height of the object is root h1, h2. These 4 results or 4 questions, they can be framed on this. Lens displacement method. Remember it. Quite important. Turning the page. Next one. Newton's formula of lengths. Hope you remember we did this in mirrors. Anyone remembers the formula? Newton's lens formula, Newton's mirror formula? Anyone remembers? If you take the distances from the focus instead of the pole, the focal length will be f square will be x1, x2. Anyone remembers that? Where did we do that? This was the formula. xy is f square. Yeah. Don't forget the results. Currently with your seniors, that's what I'm doing. We are having Viva sessions. I call their name and ask a question, they have to answer. It is fun. You should see their faces. Full syllabus, huh? We can do later on when you guys are a little free. So what is this formula here? Same stuff. If you have a lens here, object here, but remember in a lens, you have 2 focal lengths. Image here, and this is f2. So here, x, the object distance should be measured from the first focus. Image distance should be measured from the second focus. In case of a biconvex, biconcave lens object, remember in this case, image actually forms behind. So this would be x, this would be y. So be careful here. So what this thing says is x into y is equal to f square. X is the distance of the object from first focus. Meaning whichever side the light is incident, that is f1. The side of the incident rays. If the object had been on the right hand side, then f2 would be f1 actually. You can just put it in that formula 1 by v plus v1 minus u, you'll get the derivation. It's really not that important. But result is important. Mod because you don't want to take any signs here, just the magnitudes. The same formula we had it in mirrors also. Check it out. Any doubts on this? Clear? Next one. Next one. Let's say we have a light ray. At a height h here, you send a light ray. You send a light ray like this at an angle theta. And then this light ray actually, this light ray should have gone, this won't go in a straight line, remember? The light ray to the principal axis will go in a, optical center will go in a straight line. This will bend like this. This angle is your deviation. This is your refracted ray. Focal length of the lens is f. So a paraxial light ray, paraxial meaning it's pretty close to the principal axis. Is incident at a height h above the optical center. At angle theta. Theta is very small. Find deviation. The light ray through the optical center would have gone straight, but if you're sending it little high, it won't go straight. Then what is the angle of deviation? Let's get this. Others do keep your cams on. How do we proceed? It is a little geometrical, you have to figure it out. Take a minute, think about it. It's okay if you don't get it, that's totally fine. But suppose agar ye exam mein aayega and seriously it doesn't click, how do we guess? How do we guess? Tell me, like, what all things will you see to guess this from the options? Theta, क्या कर सकते theta को? Theta is already small. What will you do with it? One thing you can make theta 0. Then later we'll go through focus. That you can do. When you put theta 0, light ray would go like this. So this would be the focus. The light ray was supposed to go like this. This was h. Then this will be the deviation. So this is delta. So tan delta will be h by f. Since it is very small, you can take approximately delta is h by f. Make sense? We can do this. What else? Actually, his answer aa jayega. But what else? What if I put h is equal to 0? Then the light ray will pass through optical center. Then what's the deviation? 0. You're getting it? So in the options, I'll put h is equal to 0 and I'll see who is giving me deviation 0. 1 or 2 options jayega. Then if you put theta is equal to 0, then you'll get something of this sort. I think from here you'll get the answer. But how to do this? Now let's try. That's what I'm saying. If you can learn how to figure it out, guessing requires more knowledge. But that will give you answers. Sometimes you don't know how to solve. This is how people actually solve questions. Everyone doesn't sit with the question and start thinking. When you see a question, the first 10 seconds, right, people are thinking, can I guess this? That's what I'm saying. Just because you're good in subject doesn't mean you'll do well in exam. So writing an exam is a skill. That's a different skill set from studying. Studying is important, but figuring it out, how to guess questions is a different skill set. So when you solve questions, right, that's what I'm saying. Instead of doing a lot of questions, right, slow down a bit, see a question, अच्छे से solve करो, उसके बाद ना options देखो and see, could I guess this question in a faster way? If you can just ask yourself that question every time after doing and like looking at the options, you'll start developing this skill. Maybe starting में बहुत slow होगा, but 3 months, 6 months, 1 year, you will be like, you see a question, sometimes it just clicks. Sheer practice. It's happening with your seniors now. In the beginning, like if you see even 20 days before, right, they were struggling with some basic questions. But every day I gave them a target. They have to solve every day 60 questions per subject. Every day. Meaning unka abhi classes kuch nahi hai. They're having full day free. Everyone is studying at least 10 hours per day. Not everyone. At least 60-70%. Remaining people have to scold them. But they're putting 10 hours plus day. 10 hours plus. And they're solving 180 questions per day. Matlab 60 questions minimum. Now socho na, in a month, how many questions are you solving? 1800 questions per subject. 5400. 1 month में कुछ नहीं होगा, actually कुछ नहीं होगा. But after 3 months, 5400 questions per subject. After 6 months, you'll cross 10,000 per subject. Do you really think they'll be the same person anymore? That's the difference. Solving huge number of questions. And सब लोग किया था वो last year में. We did the same thing in revision. Last year, it was even more intense. We did almost 2,400 questions in 25 days. इतना क्यों? Today, tomorrow after the class, we have a speed test. 90 questions, 1 hour. I told you this, right? Told you? No? We have a speed test, 90 questions, 1 hour. And you know what is the highest? 81 questions attempted, 7 wrong. People are doing 1 hour. Mein. So even you guys will do next year. Mindset is what is important.
So, but the
When I
questions
said,
are easier, huh?
हाँ, थोड़ा mains level से easy है, but फिर भी 90 questions reading will take away half your time, right?
Yeah.
You guys are very bad at reading.
हाँ,
You
but
see the
then
question,
more
you
or
read
less-
the same thing 5 times.
But then more or less formula based ही होगा ना.
हाँ, एक बार try करते हैं मैं. बोलना बहुत easy है. You should see them after 1 hour. Huh? Literally everyone is exhausted. And उसके ऊपर I'm there in front of the screen ना. Every 10 minutes I keep scaring them. Time's over. Question हो गया, वो हो गया, ये हो गया करके. It is fun. You should see them faces. The last 10 minutes when I say, people are struggling. People are like this, सब कर रहे हैं. How do you do this thing? See, like I said, this is a little more geometrical question there. So this is your pole. This is the point where it goes here. This was supposed to go like this, but it goes off like this. That is your delta. So if you send one more light ray parallel through this pole, Same thing at an angle theta. This also would have gone in a straight line. So basically this green line, which is deviating, will eventually go and meet somewhere here. What will be that point there? Remember, parallel rays will meet at focus, isn't it? If you send a parallel light ray through the optical center and through this line, they will meet at the focus. So this is where they will meet actually. This is the point where the light parallel rays meet. And look at the angles here. This was height h. And this is delta. So that is theta. So this angle would be theta. Let me draw a new diagram again here. So this is the focus. This is the point H. This light ray would go somewhere. It looks so messed up. This is there. This is where they're meeting. Okay. Let this angle be phi. This also will be phi. This angle is theta. So this angle also will be theta. This height is, I don't know how much is that height, but I can find that. This total distance is focal length f. So from geometry, this will be f tan theta. Perfect. And let this distance be, again, derivation is not important, result is more important. We will see that. If this is x, this guy will be f minus x. So from there we get tan phi will be f tan theta by f minus x. Right? And here what you can do, since theta is small, and what is also tan phi from here? And we also know tan phi is also h by x from this triangle. So tan pi is equal to this, tan pi is also h by x. So for small theta, tan theta is almost equal to theta for small theta. You end up with f theta by f minus x is equal to h by x. Cross multiply, you end up with xf theta is equal to fh minus fx, and x will be fh by f theta plus f. xf theta, f theta minus x. Yeah. Perfect. So what do you want to find here? Deviation, no? So what is the deviation here? So the phi what we got is this angle. This total angle is phi. And what is theta? This angle is theta. This angle is deviation. So from here we get deviation delta is nothing but phi minus theta. This is messed up. So this is one result. And we also know tan phi is approximately phi for h by x. So phi is h by x, and actually यहाँ से theta निकालना था. So f. Wait. Phi minus theta is the deviation. Phi का value h by x. I want to get an answer of h and f ना, तो आज मुझे x नहीं चाहिए था actually, right? That is fine. Minus theta. Take this x and substitute here. I will leave it here. It's too messed up. Final answer आएगा h by f. So just remember the result. The derivation is bad. Actually, when you took theta 0 by answer आया था. So deviation is h by f. Keep this in mind. Proof is bad. The result is more important. So if you send a light ray at a small angle, the deviation will be h by f. If you take this x value from there and phi and subtract it, there are too many approximations because there's this thing. But got the basic idea what we did? Just geometry there. So you took this as one triangle tan phi, and then you took this as one triangle tan phi. From there you got x value. Once you got x value, you found theta and phi in terms of approximation x value, and then phi minus theta is the deviation. Cross multiply, result is hf minus hx. Hx होगा ना? Then I won't get it. Then क्या था ये? Then this would be f theta plus h. I goofed up there. You wouldn't have got the answer without that. Okay? Yeah, that was a mistake. Right, Neil? Anyways, that is one tiring derivation, but the formula is more important. Next one. Anyone not clear with this? Just go there and check it out. It's just geometry there. So the points will meet just below the focus, because parallel rays always meet at the focus. The next one. Optical power. So what is optical power? The ability to converge or diverge light rays. So this is a convention normally. Converging systems have positive power. So if a system is converging light rays, we say it as a positive power. Most of us, right, we have glasses negative power. My eyesight is minus 5.5. I have positive power. That means what is happening now? If this is my eye, whatever the light rays are coming, they're actually going and falling in front of the retina. So I need a lens which will not converge but diverge a bit. Meaning after going through this, the light rays will diverge just slightly more, and then they'll go and form on the retina. So people with the negative glasses power, right, we are using diverging lenses. Some people have a problem, they can't read when it is too close. So I think this is called क्या था myopia and दूसरा कुछ तो था नाम. Something is there.
Hyperopia.
कुछ तो था. So for these people, right, the light rays are actually going and meeting behind the retina. So you need a lens there which can bend these light rays much closer. So this is a converging lens. They use glasses with positive power, but most of us actually have negative power. The next time when someone says, no, my glasses ka power is -3, -1.2, that's what they're meaning. The minus indicates that using a diverging lens. Diverging systems, we treat them as negative power. Just a convention. Hypermetropia. Okay. Something of that sort. You can still remember bio itna pad liya 10th mein.
Yes.
So power of the lens is given by 1 by f of the lens. Be careful, focal length should be in meters, SI units. Because for a normally biconvex lens, focal length is positive, so it's converging. The units are diopters. Example, if I take a focal length f is equal to 20 centimeters, so power of this lens is 1 by 20 centimeters is how much? 1/5 of a meter, no? So 0.2 meters. So that is 5 diopters. Be symbol as 5D. That's the power of a lens. Now here you have to be careful. For mirrors, it is a reverse. Because in mirrors, what happens? A concave lens is converging, but it has a negative focal length. So therefore, we introduce a minus sign to take care of that, to make it positive. Example, if you take a convex lens, convex mirror, let's say f is 10 centimeters. The power of this concave mirror is minus 1 by, here f is 0.21, the minus 10 diopters. So even mirrors have power. So be careful, mirrors will have a minus sign, lenses will have a positive sign, plus 1 by f and minus 1 by f. Oh, even in physics it is there. Do check this out. Clear? Next thing. So what happens if you combine lenses? Combination of lenses. So if you take multiple lenses, convex, convex mirror. Yeah, my mistake. So if you take lenses, focal length f1, f2, so on till fn. So this is what we can do. Object is there, so we can write the formula as 1 by v1 for the first lens is 1 by u is equal to 1 by f1. So for the second lens, the image of the first lens will be the object. So 1 by v2 will be 1 by v1. Again, this is valid only for thin lenses. So on, if you do this, you end up with 1 by vn by 1 by vn minus 1 is 1 by fn. So when I add all of them, cancels off. And you end up with 1 by, the v final one is 1 by u is equal to summation sigma, like 1 by f1 plus 1 by f2 plus so on till 1 by fn. So this formula, right, whatever we get here, you can write this thing as 1 by f equivalent is sigma 1 by fi. So from here we can write this is the power of this combination. And the whole thing will behave like a lens, simply power of the first lens, power of the second lens, and so on. Sigma pi. So if you have multiple lenses, you can just add the power. Remember, you can't add the focal length, you have to add the power. But this thing, right, is valid only if all have same principal axis. Valid only if first one, lenses should be thin. So this total distance, right, must be negligible. Second, all have common principal axis. If you keep one lens like this, formula is gone. It's not valid. Common principal axis. So you can't have lenses like this. This won't work. So this is quite useful. So if you give me 10 lenses, right, instead of using the formula 10 times, I can just use this F equivalent and treat them as one single lens. Clear with this? And this whole combination behaves like a lens. Can replace the whole thing with a single lens. Clear? Any doubts on this? Hi, Vidyut? Malika? If you see, Adrit, the moment you say thick lens, kya hoga? Lens maker formula itself is wrong, no? Then you go back to which one? Then you go back to refraction on curved surfaces. That means the question would be like this. You're doing questions on refraction on curved surface. You can't even use lens ka formula, Gaya. You have to go back to the refraction on curved surface and solve. So let's say example of what you're asking. Someone gives a lens like this. Thick lens. Let's say this is 5 centimeters. So then you're gone. Refraction on curved surface, get an image. Refraction on curved surface, get an image. You have to solve 2 times. What is the criteria? That is the thing, because you guys don't revise the notes. You don't see that. What is the criteria for a thin lens? Ask the question in the reverse. Then you will find. For a thin lens, what is the condition? The thickness should be much smaller than radius R1 and R2. Isn't it? That is the criteria for a thin lens. So if this thickness is very not comparable to the radius, it is thick lens. Clear with that? Yeah. Great. Next thing, what happens if you have a mirror and a lens? Aryan, clear now? Great. What if you place a lens and a mirror together? So let's say we have a lens, and we have a mirror. And let's say this lens's power is P1, this lens is P2, and this PM is the power of the mirror. So if a light ray enters and then leaves, if you see the number of refractions, this passes through multiple lens 2 times. Each lens it passes through 2 times. So this can be treated as 2 lenses. Then it goes through a mirror. Then again it goes through 2 lenses. So the light ray will feel it has passed through 2 lenses, mirror, then again 2 lenses. You're getting it? So this whole combination, so light ray feels it has passed through 4 lenses. It is just coming back through the same lens. So for it to end of the day, it is a refraction only, even though there are 2 lenses in reality. So this whole combination, first of all, will behave like a mirror. This is given by 2 times P1 plus P2 plus 1 mirror to PM. So this is a formula, 2 sigma power of the lenses plus mirror. So whenever you have a mirror, this is what happens. Later on, I'll show you a case, where if you have multiple mirrors, what happens? This combination behaves like a mirror. Have a look at this. Just have a look at this. I'll just be back in a minute. Yeah, let's see. Play with this. Any doubts on this? Why we're using two lenses and all that stuff? Great. Now tell me one thing. How do you decide whether a combination is a mirror or a combination is a lens? यहाँ पे तो दिख रहा था, but how do you decide normally whether a combination is a lens or a mirror? Can someone tell me what is the crucial difference between a lens and a mirror? Anything that you think of.
mirror.
Has two focal lengths. Lens is a single focal length ना रे, two कहाँ से आएगा? मतलब two focuses. Lens is in silver coated. वो ठीक है. Anything else? Position of image with respect to lens or mirror? ना वो भी नहीं है.
Lens help
Yeah.
to converge or diverge light.
I'll give you more clarity, like in terms of light ray का propagation. Mirror makes real image on same side. नहीं. Maulika, I think you're saying it. In terms of light propagation, see, no matter which lens you take, this is a very important thing. Useful to figure out whether something is acting like a mirror or anything. A combination behaves like a lens if the incident ray goes on the same side. Meaning, suppose if you have a lens, this is a very important idea here. Later on, you'll understand. I'll ask you a question where it is a little weird. Suppose you have a lens, and let's say you have a lens like this. See what happens. If you send a light ray, this will try to converge. This light ray will try to diverge. And this light ray again will try to converge. So if you see, the light ray is still gone in the forward direction only. But if you take a mirror में light ray will always come back. System behaves like a mirror if the light ray reverses. Exactly not 180 degrees turn, but it will make a obtuse angle kind of thing. So if you have a lens and if you have a mirror, take any mirror, doesn't matter. You'll observe the light ray enters, hits, comes and goes off like this. It will come onto the same side. So basically it is based on the propagation. So in this case, you have to use the formula 1 by V minus 1 by U is 1 by F of the lens. In this thing we use 1 by V, so the formula changes. 1 by F of the mirror. हाँ आर्यन, वो देखते हैं next class में. What happens if there is a TIR? That's a good one. So TIR is what? It's like a mirror only. Have a look at this. Is this concept clear, everyone? Let's see some questions. Let's say we have a lens. We have a lens. Let's say this focal length is 10 centimeters. This focal length is 20 centimeters. This is the object here, thin lenses, and this is 20 centimeters. Find the position of the image. It's the same question. You have a lens, but this time someone silvered this side also. And let's say radius is 20 centimeters. Same question. F1 is 10 centimeter, F2 is 20 centimeters. The object is a 20 centimeters. Again, all are thin lenses. So basically this can be treated as a lens, and you can treat this as a mirror. So we can assume a thin area gap between the lens and that silvering. So basically it becomes like two lenses and one mirror. There, let's get this thing. First find the focal length in both the cases and find the images. First case is just two lenses. Second case, there is a lens and a mirror. Right, just substitution there. B is 20. Let me show you the first one. First one, if you see the first lens P1, 1 by F1, that is 10 diopters. Remember, it should be in meters. 1 by F2, that would be 5 diopters. So the power of the lens combination is P1 plus P2. And the lens combination is 1 by F length. That would be 10 plus 15, 15 diopters. So we get F is equal to 1 by 15. Remember, this is in meters. So 100 by 15 centimeters. That is 20 by 3 centimeters is the focal length of this full combination. Then apply the formula length na 1 by v minus 1 by u is equal to 1 by f length. So 1 by v, this will be 1 by u is minus 20, and this will be 3 by 20. 3 by 20 minus 1 by 20, 2 by 20, v is equal to 10 centimeters. Check. Please check how I did this. So I found the focal length of each one. Remember, f1 and f2 should be in meters. This should be in meters. So once you got the equivalent focal length, that will be equal to 1 by f length, equivalent length. So you basically replace the entire thing with one single length. So what you did was, this whole setup you replaced with one lens f combination of 20 by 3. Question simply became there's an object at 20 centimeters and you're done. That's what we did. Any doubts on this first part? Please ask. Get the second part. Okay, someone got 20 image forms on the object. We could just add one. We could have done that. But वो problem क्या होता है ना, when you do it for mirrors, right? Mirror में formula minus sign is there. There you'll goof up. So I don't prefer that because I like to add powers every time. If I use 1 by f1, 1 by f2, you can do it. Then you for a mirror, you'll put minus 1 by fm, but you have to be careful while writing it. So if you are comfortable with that, you go ahead. No problems. I'm not comfortable because I don't trust myself with a minus sign. So it is always that way. Remember, meaning 10 teachers will teach you 10 different things. You should see what you are most comfortable with. If there are 3 methods and you feel like method 1 gives you the answer very fast, but you're not comfortable. Method 2 gives you answer, but it takes you 30 seconds more, but you're quite confident, then use this. Okay, 1 by 20 got cancelled on both things. Cancel हो गया? मतलब how? Okay, so you got the answer quite fast. Fine. What about this guy? So this can be treated as lens. Lenses, I think you could do it. I'm just worried about whenever there's a mirror. So what is the power P1? So P1, अभी calculate किया था. P1 is 10 diopters. P2 is 5 diopters. So this is also P2 is 5 diopters and P1 is 10 diopters. And power of the mirror will be minus 1 by Fm. This is a concave, so minus 1 by minus 10 centimeter. So that would be 10 diopters. So this power of this whole combination, which will be a mirror, will be P1 plus P2 2 times plus 1 mirror. 15, 15, 30, 40 diopters. Hope I'm right. This should be equal to minus 1 by F mirror. Remember, power of a mirror is minus 1 by F. Am I right? Or I goofed up somewhere? 10 plus 15, 15. R is minus, focal length is minus 10, so 10 diopters. Looks right. So this would be minus 1 by 40 meters. For 100 by 40, 10 by 4, minus 5 by 2 centimeters. That's your focal length. So this whole combination is a concave mirror whose focal length is minus 5 by 2 centimeters. Object is at 20 centimeters. Now remember, this is a mirror, so use mirror formula. 1 by V plus 1 by U is 1 by Fm. That's what I'm saying. Can you see how many minus signs can come? The formula will change. Mirror ka power mein there's a minus sign. So 1 by V, unless I didn't goof up any calculations. Please check. If I goofed up, let me know. This guy is minus 2 by 5. So 1 by 5 minus 2 by 5 plus 1 by 20. Multiply 4 minus 4 to 8 minus 20 by 7 centimeters. Check your answer. 7 आया रे मुझे. Is this making sense? Yeah, check it out. I think we got, someone, Anush also got 20 by 7. Please look at the steps. So you just treat each lens as a lens, P1, P2, 2 times, and mirror, get the equivalent power, then put minus 1 by Fm because it's a mirror. So here, see, यहाँ पे एक minus n आएगा. Then यहाँ पे minus n आएगा. Then again यहाँ पे this plus becomes actually that is lens में minus and this में plus. There are 3 places where you have to be careful with the minus sign. Please check this. Clear? Next thing. Any doubts on this? Anyone not clear with this? Please ask. I hope you're getting now how to use this. So this way it will be quite useful if you have multiple lenses also. That's an easy one. Let's say we keep a slab. Mu is equal to 2. Outside is vacuum. This is a straightforward question. The power of this lens is 2 diopters. So someone took this and it's placed in a liquid. Liquid is 4 by 3. This is mu is equal to 2. Find the new power. If you take a lens and put it in the liquid, the focal length changes. The things will change. This is what happens when you go underwater, right? Even with your goggles and all, you still can't see clearly. So in vacuum, the power of this lens is 2 diopters. When you put this lens in a medium of 4 by 3, what is the new power? Get this. Easy one. Get the answer. Any answers? Mehan, keep your cam on. Venkatesh, cam on, everyone. Four diopters. I was not expecting that. See now. What is 1 by focal length here? 2 minus 1. 1 by R1 by 1 by R2. Whatever is that. Okay, so this is P1. This will be P2. This will be the new focal length 1 by F2, which is 2 by 4 by 3 minus 1. 1 by R1 by 1 by R2. If you just divide them, you end up with P1 by P2. This will be 1 by 6 by 4 minus 1. This guy is 2 diopters, and this is P2, and this will be 3 by 2 minus 1, 2 na? So P2 is 1 diopter, no? Yeah. That's it. You just have to find the focal and then finish it off. Clear, everyone? Aryan? Arjun? Clear, no?
Yes, sir.
Be careful. That 1 by F and F thing, you have to be careful. Last one. We have a lens. We have a lens. And someone silvered it. So we got a mirror. Radius of the mirror is 40 centimeters. The first lens ka focal length is 40 centimeters. The second lens ka focal length is minus 40 centimeters. This is 10 centimeters. Be careful, huh? Sometimes they won't give the sign. They will say focal length of a biconvex lens is 10, focal length of a biconcave lens is 40. So you need to understand there's a minus sign. So they will not mention it every time. And there is an object here at a distance x. Find x if the final image forms on the object itself. We have done these kind of questions. Let's finish off. Last one. Find x if the final image is on the object. Udayan, try. No answers from you today. Ronak, you also didn't answer anything today. Ranjan, Vastika, no answers today. Make sure to revise your class notes on daily basis and start doing work on this thing. Do finish off your booklet or DC Pandey, or if you're doing my booklet, you can go from level 1 to level 4. Do start solving. If you wait for for the chapter to get over, by then you'll forget everything. $16. Okay. Anyone else got 16? I don't know the answer. Let's see. We have one answer, 16. First, find the power of this combination. This whole combination will be like a mirror. So figure out what kind of mirror it is, question is done. Let's see. So this can be treated as lenses. So P1 is 1 by 10, so 10 diopters. P2 is 1 by minus 40 is minus 0.4 minus 2.5 diopters. Power of the mirror is 1 by Fm. Here Fm is positive, that is 20 centimeters. So that's 0.2, that is minus 5 diopters. So power of this whole combination, which acts like a mirror. So if there's one single mirror, the whole thing becomes a mirror. 2 times P1 plus P2 plus Pm. That would be 10 minus 2.7.5, 15 diopter, and this guy is minus 5 diopter. This is 10 diopter. Since the whole thing is a mirror, this is minus 1 by FM. So FM will be minus 1 by 10 meters. So this is minus 10 centimeters. That means this whole setup is behaving like a concave mirror. That's the meaning of negative focal length. Suppose focal length is 10 centimeters. Therefore, radius is 20 centimeters. So the object is at the center. So this entire combination should think the object should be at the center. Then the image will be at the same place. So if the combination mirror sees the object at the center, image will form at the center again. So that should be 20 centimeters. So if you keep x is equal to 20, the whole combination will think the object is placed at the center of this concave mirror and done. Easy? Please check. Combination of lenses and mirrors is not tough. It is just you have to apply the formulas appropriately and you'll get back either a lens or a mirror, and then from there you can do as usual. We're almost done with this also. We have another 2-3 more cases on this. So on Friday when we catch up, we will do that, and then we'll do prisms. Prism we didn't do. Prism is again completely theoretical. But even in that advanced way, they did ask 1 or 2 questions. We'll see them. Prisms I'm sure you did in school also. The delta graph, deviation, same stuff. So that we will do it on Friday. So Friday we'll wrap up the chapter though. What's left is only prisms. It's not much. So Friday also will catch up as usual at 6. And next week so we'll start at 5:30, like all Friday, Wednesday also. We'll start with centromers from next week. Currently पेस में क्या चल रहा है? Did they finish off ray optics?
So
Still go on.
Where did they reach? Lenses is going on. Centromers, where did they reach?
we have to start